This lesson is 9-1 from your book. This is an introduction to polar coordinates, and we're also going to talk a little bit about complex numbers. So polar coordinates compared to rectangular coordinates. We know that rectangular form, if we're looking at coordinates, is some x and a y. We have parentheses x comma y. And that tells us how far we are on our x and how far we are on our y. In polar form, instead of x, y, we have r theta. But it's related to that x and y. So let's look over here at this triangle on the right. We should remember some of this stuff from vectors. So we are given some x and some y. So we get this point over here, which means we went this far on x and we went this high on y. And we end up with this point here. Well, we can talk about that point as an r and a theta also. We know that if we're given some x and some y, that if we wanted to find r, which would be the hypotenuse, we would just do Pythagorean theorem, which is x squared plus y squared equals r squared. Now, similarly, if we were given that x and that y and we wanted to find theta, we could consider inverse tangent. So inverse tangent of our y over our x will equal our theta. So that's how we can derive and go in between those two. We can also look at if we were given the r and the theta and we wanted the x, we could do r cosine theta equals x and r sine theta equals y. Using that same information, complex numbers, you'll notice instead of graphing on x and y, we are graphing on real and imaginary. So if we were given some complex number x plus yi, we could call it 2 plus 3i or something like that. We would be able, let's make up a nicer one, so we'll do 3 plus 4i. So that means we have 3 on the real and 4 on the imaginary. This x value would be 3, this y value would be 4. And so we create the same triangle. We could similarly, the way that the trigonometric form is written is instead, so if we start with the trigonometric form x plus y, or if we start with the complex form x plus yi, we have the trigonometric form, which is r parentheses cosine theta plus I sine theta. And we find that r and these thetas in exactly the same way as we did before. So you could say x squared plus y squared equals r squared. You could say that inverse tangent of y over x equals theta. And again, we could say that x is equal to cosine r cosine theta. Sorry, x equals r cosine theta. And y equals r sine theta. So these work the same way, and then you're just plugging that information in. So let's do an example. Let's look at graphing a specific point. So let's graph the point 2 and 45 degrees. So that means our r is 2 and our theta is 45 degrees. So where is r2 on here? Well, if we're graphing in polar, here's what we look at. So each of these rings is r value. So we're going to look at this being r1, this is r equals 2, this is r equals 3, and r equals 4. And the angle, that theta, is just where we would expect it to be if we remember our unit circle, so, or any circle. So we are 2 on our r and we are 45 degrees on our theta. So we are on this 2 loop and we end up at 45. That means we had an r value of 2, that length is 2, and my theta that I moved was 45 degrees. So that spot right there, this is r2 45. Let's look at another point. If we were to graph the point 3 and 4 pi over 3. So again, we're going to go out 3. We are 3 on our r. So 1, 2, 3. That means we're 3 on our r. And then we are going 4 pi over 3. So we have to find that. Where's 4 pi over 3? We're going all the way over here. And this is, oops, sorry, a little farther. This is where we end up at 4 pi over 3. And we were 1, 2, 3 on our r. We end up right at this point. Okay, let's graph another one. What about the point negative 5, 150? We haven't dealt with negatives yet. Maybe that's not sure exactly how we should do that. So let's go, we know we're going to be a 5, right? 1, 2, 3, 4, 5. We're on this line here, 1, 2, 3, 4, 5. And we're going to go over to 150. So we are over here now. That would be a positive 5 and 150. Well, what if I wanted to do the negative? If we want to do the negative, we just go across that center. So we're going to go actually to this 330, 1, 2, 3, 4, 5. And this is going to be the equivalent angle. So what we could call this is the same as positive 5, 330 degrees, that's an equivalent place to graph this. So just like when we were coming up with coterminal angles, we can have the same coordinates or different coordinates like 5 and 330 or -5 and 150 end up at the same spot. The last part of this lesson is going to talk about now functions. So when we talked about Cartesian planes, we can graph points, we can graph certain coordinates, or we can also graph an equation or a function. So let's look at the most basic function. R of theta equals 2. So R equals 2 is essentially our equation. So that means for any theta, no matter what our theta is, we're going to have R equal to 2. So we would go out here and we would plug in, if we plugged in 0 for theta, we still get 2. If we plug in 0 for theta, we still get 2. 0, we get 2, 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 over and over and over again. So the shape that we have is a circle. We have a circle at that radius or that hypotenuse of 2. That's what that graph looks like. Okay, the last thing we're going to think about is our distance formula. So if we had 2 points, 1 point here and 1 point over here, and we were trying to find the distance between those 2 points. Well, we remember from algebra that we can use this distance formula. Essentially, it's just a version of the Pythagorean theorem. If we have some xy here and some xy here, if we wanted to find the distance between them, we would look at what's the difference on our x. Oops. What's the difference on our x? What's the difference on our y? And that would give me some a squared plus b squared equals c squared business, which is exactly what we have over here. We have s squared equals x1 minus x2 squared plus y1 minus y2 squared. Now in polar, our x is equal to r cosine theta. So we're going to have some r cosine theta 1 and r sine theta 1, and then we have each of those values that corresponds. So here's this all worked out. You know, you plug in your r1 cosine theta 1 and r2 cosine theta 2 for x1 and x2, r1 sine theta 1, r2 sine theta 2 for y1, y2. And you work that all out, the squares, we end up having a FOIL. We get this equation, r1 squared plus r2 squared minus 2r1 r2 cosine delta theta. So this should look familiar to you. This looks just like law of cosine. So if we had some a squared that we were trying to find, which would be maybe some part of our triangle, we'll call this a, we would do b squared plus c squared minus 2bc cosine of that angle a. This is exactly the same thing, except now we have some r, some distance 1, and some r, some distance 2, and we're looking at the theta between those two. So that's how you do distance formula for polar coordinates.